and this is also denoted by, maybe यहीं पे लिखता हूँ मैं, it is also denoted by this, that is dou of f1 f2 up to fm upon dou of x1 x2 up to xn. This is one more notation for Jacobian matrix. Either you say this or say this, both the things are same. Is that clear? Let us see one example. Suppose you want to, in the question, find the Jacobian matrix. Of the following vector field, say f r2 to r3, and f of xy is given by 2x square plus 3y, 4x minus 2y, and say x cube plus y cube. Suppose this is your function, you want to find Jacobian matrix. So can somebody tell me what will be the order of Jacobian matrix here? There are three functions, f1. What will be order? Anybody? Yes. What will be Jacobian matrix? से Jacobian में at कोई point पे बोलते हैं, at 1, say -1, 1 पे बोलते हैं. So suppose this is your function f1, f2, f3, and Jacobian of function. So what is Jacobian of function? Jacobian of f of -1, 1, that will be, another notation is dou f1, f2, f3 upon dou x1, x2, x1 and x, sorry, x and y. Here there is no x, here we are considering x and y, and with respect to the point minus, for the point 1 and -1 and 1. So what will be this equal to? What will be the order of matrix first? Tell me. Order of matrix. It will be 3 cross 2, correct? 3 cross 2. There will be 3 rows and 2 columns. Something like this. So क्या आएगा यहाँ पे? Dou f1 by dou x at जो भी point हो -1, 1, and same dou f1 by dou y, correct? Same thing, dou f2 by dou x, dou f2 by dou y. Like this, correct? Now you just have to substitute and put the value. That's it. That matrix you obtain, that will be your final matrix. So क्या आएगा देखो, f1x with respect to x क्या, तो क्या आएगा, this will be 4x and -1, 1 अगर रखा तो ये क्या आएगा, -4, करेक्ट? 1 ही रखते, छोड़ो -1 से, let us get rid of that. Correct. What is this? Do f1 of x 4x आया, so it will be 4. यहाँ पे क्या आएगा with respect to y, this will be 3. यहाँ पे क्या आएगा, it will be 4. यहाँ पे क्या आएगा, -2. With respect to x it will be 3x square, so it will be 3. With respect to y it will be 3y square, 3. correct? So this is the matrix, this is Jacobin matrix of order 3 cross 2. That's it. So whenever you are having any question and the question is to find Jacobin matrix, you should do this, correct? When you put m equal to 1, it will be your gradient vector. So j f of e, that will be your gradient vector. Dou f by dou x 1, which I already told you. Dou f by dou x 2, dou f by dou x n. Correct? Hence, what can you say? Hence, the Jacobian of a vector valued function is the extension of gradient. करेक्ट. सो जो भी ग्रेडियंट था उसी को हमने एक्सटेंड किया ओवर एम वेरिएबल, सो दैट इज योर जैकोबियन. नाउ दैट इज ओके, ठीक है. नाउ लेट अस सी हाउ दिस इज रिलेटेड टू योर डेरिवेटिव. करेक्ट. हाउ दिस जैकोबियन मैट्रिक्स इज रिलेटेड टू योर डेरिवेटिव, एंड दैट इज क्वाइट इजी टू अंडरस्टैंड कि क्या रहेगा वो. दैट इज जस्ट मल्टीप्लाई कर दो वेक्टर, दैट विल गिव मी योर टोटल डेरिवेटिव एक्चुअली. एंड टोटल डेरिवेटिव अगर एग्जिस्ट होता है तो वो यूनिक होता है, ये भी थ्योरम देखा है. सो लेट अस जस्ट रीड द थ्योरम फर्स्ट. एंड पहले यूनिकनेस का देखते हैं. यूनिकनेस इज इजी टू प्रूव. 1 derivative of a vector valued function if exist is unique. So uniqueness proof करना है. Can you do that? How will you do? Suppose if possible, पहले तो फंक्शन डिफाइन करते हैं. Let f from S that is in Rn to Rm be a vector field. Okay, and let us say f is differentiable. F is differentiable at some e belongs to S. This is what we are given with. Now we want to prove that the uniqueness, no? So suppose if possible there are two total derivatives, say t1 and t2. Say t1 t2, the domain and range will be same, Rn to Rm. Correct? Such that df of e that is equal to t1, and again df of e that is equal to t2. So these are the two total derivatives we are having. What we have to prove? We have to prove t1 equal to t2. Correct? t1 equal to t2. That means what? That is to prove t1 of h equal to t2 of h for all h belongs to Rn. That was in one variable. Okay? So how will you do? You want to prove both are equal, so how will you prove? Suppose not. Suppose t1 of h is not equal to t2 of h. correct? Or yeah, suppose it is not equal, then what can you say? Or maybe you can say at t1 at e, because we wanted to consider at e now. So see, there are so many ways to prove this thing. See, you can use the definition, and by combining the epsilon delta you can get that also, तो वो भी चलेगा. Or do anything else, तो भी कुछ भी, मतलब whatever you wanna try you can. So suppose t1 of a is not equal to t2 of a, but both are linear transformation. Can I define a new t? Let t of a equal to t1 of a minus t2 of a. Can I do that? Yes. So this t of a is non-zero. That is what I know by my consideration. Okay. So now let us relate this h. Let h equal to ta बोलते हैं, and where t is any real number, where t belongs to R. So what can you say about this limit? Limit as tending to 0, norm of th with m coordinate upon norm h with n. What can you say about this? H tending to 0, but what is your h? That is limit ta tending to 0. So it will be at the place of h you will write ta. Since it is linear transformation, you can take t outside, correct? So if you take t outside, it will be mod t outside. Then since it is a real number, mod t will be outside, and here it will be norm of t of e m upon, here also mod t will be outside, it will be norm of e n. So this is cancelled, and you are having this guy, that is here it is a non-zero number, so it will be at a, yeah, ta. So a is constant, a is a number, so it will be t tending to 0, but there is no term of t now, so the limit will be this only, norm of t of e upon norm of e n. Now you must be wondering, sir ये मतलब क्यों किया हम लोगों ने, what is use of it? So let us see. If you take the first d1 or d2 का definition लिखो, then you'll get this. Let us stop this here and let us write the definition of t1. You know that df of e, that is equal to t1. So what is definition? That means limit h tending to 0, norm of f of e plus h minus f of e minus t1 of h, norm m upon norm h upon norm n, that is equal to 0. This is first thing, and same thing, df of e equal to t2. What do you mean by that? That means limit h tending to 0 again, and you'll be norm f of e plus h minus f of e minus t2 of h divided by norm h, that is 0. Correct? Okay. Now let us consider this. I want to relate both the thing na, so let us consider this consideration part. Consider norm of t of h upon norm h. This is with m, this is n. Let us add and subtract. t मतलब अपना original t जो भी हम लोगों ने माना था subtraction. Let us add f of e plus h, f of e minus h. So first of all you may write t of h क्या है, that is t of h1, t1 of h, this is t1 of h minus t2 of h, and divide by norm h. So if you add that, so you will be having what, थोड़ा सा मैं आगे बढ़ूँ तो by adding and subtracting f of e plus h, I will be having f of e plus h minus f of e minus t2 of h, and here t1 के लिए प्लस में रहेगा, तो you need to take minus f of e plus h plus f of e and plus t1 of h. norm m, यहाँ पे m n लिखते जाने का because we are having different norm. This is norm h. Can I use triangle inequality? This is less than equal to, yes, this is less than equal to this and this, so that is norm of f of e plus h minus f of e minus t1 of h m upon norm h. I would like to use my sandwich theorem. A plus h minus f of e minus t2 of h divided by norm h. If you take limit both the side, what will you get? If you take limit both sides, these two people go to 0, so this guy must go to 0. Since this is always positive, so this guy is lying between 0 and 0. So you can say by using sandwich theorem, lower bound is always 0. I hope you clear with that. Lower bound is always 0 since it is norm. So you are getting that this guy 0 is less than equal to norm of t of h upon norm h, that is less than equal to again 0. And here limit h tending to 0 when you take limit. So what can you say now? This limit is 0, so what can you say? Does this give a contradiction? Norm h is a variable, this limit is 0, that means what? See, limit h tending to 0, norm of t of h does this give a contradiction to you? See, अभी now I'll tell you starting में मैंने क्या किया था. From here, do you see that this limit, this is norm of t of a upon, so ये limit का value आ रहा है, this is constant and which is non-zero. This is norm of t of a upon norm a, because t of a I am considering non-zero. Correct? So this limit is non-zero from here. You can put equation 1. This guy. So that's why start में मैंने ये किया था. So this give this is equation 2. So 1 and 2 contradicts each other. So our assumption is wrong. So what is that? So hence t1 of h is same as t2 of h, that is limit is exist. The total derivative of f at a if exist is unique. Let us quickly go through. Main motto is this. You want to prove this, so इसको थोड़ा side में रखते हैं. Let us write the definition. You write the definition. Now I'd like to consider this guy, norm of t of h minus h. But let us do something for that. So मैंने क्या किया, for e here t1 is equal to t2. This is to prove that. So suppose t1 of e is not equal to t2 of a at some point e. Okay, so let t of a will be the subtraction. This is again a linear transformation, and this e I can write h as t times a. I can write my h as t times a, where t will belong to real number. So this will be limit as tending to 0. This will be like this, and so this limit will be this, and which depends on only a, and that is t of a is already non-zero. So I am having this term as non-zero. This whole term as non-zero. Now the same thing I will be finding out by using definition of total definition of vector field. df of a t1 this, df of a t2 this. Then let us consider this thing जो अपने को चाहिए था. This is already greater than 0, so 0 is lower bound for this. And add and t of h को put करो, add and subtract f of a plus h minus f of a, and that's it. If you put it, you'll get by if you take limit. So I'll try to use sandwich theorem. Lower limit is already 0, upper limit this is 0, this is 0, so this guy is lying between 0 and 0, so limit is 0. This contradicts your equation 1. Correct? Hence it is proved. One more theorem is there, that is, say, I'll just state this theorem and try to prove this. S be a non-empty open set, open subset of Rn, and let f from S to Rm be given by f of x equal to, there are m variables, so f1 of x, f2 of x, and so on, fm of x, for all x belongs to S. Then f is differentiable at E belongs to X if and only if each fi is differentiable at E, and this is CMS sequential continuity में जैसे किया था हम लोगों ने. Sequential is not a good word here. Component function. The function is continuous if each of the component is continuous. Same here also, this function is differentiable if each of f1, f2, fm are differentiable. As simple as that. So that will be df1 e u comma df2 eu and so on. dfm. Yes, so this is your directional derivative. So total derivative. So that means what? If one of them is not differentiable, so you can say that your function is not differential. This is different only if. And proof is quite simple. If you go with the definition, norm, just you have to play with norm. जैसे हम लोगों ने sequential में किया था, और continuity of each of the component is continuous, then it is continuous. So जैसे किया था, same thing is here also. You just have to play with mod. For f1 this will be a scalar field, na? So you just have to consider like that. Okay, I would like you to try this and you may send it to me. You can take the help of your previous, that is continuity का part, limit का part में भी किया था हम लोग ने same thing. So you may take that help and try to prove and show it to me. Correct? Yeah. Okay then, thank you so much everyone. See you in the next class. Bye.